Hi everyone, this is the video for Algebra Section 12, solving simultaneous equations. I'm sorry if you can hear the wind, it's super windy out there. I've moved a bit, but anyway, we're just going to go with it. This is the last video on the algebra section. I'm actually moving on to a different topic after this. So in this video, I'll give an overview of the topic, I'll then go through the worksheet, and finally I will answer the questions that are given on the worksheet. If you are watching this on Instagram, then the description box below gives a link to the full video, which is on YouTube, so go ahead and check that out. If you're watching this on YouTube, then the description box below gives a link to my Instagram page. On here I post images of the worksheet and the answer sheet. So you already know how to solve equations. We've gone through this in previous videos. You usually get an equation and it contains an x, and you have to use techniques such as factorizing, rearranging, completing the square, or using the quadratic formula in order to find what the value of x is. In this video we're still solving equations and we're using all of those techniques. The only difference is the equation that you're given doesn't just contain x. It could contain x and y, and you have to find both x and y. Now, when you have an equation that contains two things you have to find, you're going to need a little bit more help, and maths is just cruel, and the way maths helps out is it gives you another equation. Hey! So if you're given an equation and it contains two things that you need to find, e.g. it contains x and it contains y, and you need to find the values of those, you're going to need two equations to help you find x and y. If you had an equation that had x, y and z in it, i.e. you've got to find three things, you would need three equations to help you find those values. This act of using multiple equations to find multiple things is called solving equations simultaneously. I actually hate that name. I think it makes it sound way more complicated than it is. Essentially, when you solve stuff simultaneously, you are still solving equations, but there are a few more things you need to find. Because there are a few more things you need to find, you need a little bit more help. So instead of solving equations individually, you're going to solve equations together. Like, oh, that's real nice of them. They're coming together, they're going to help you out. That's all it is.
Alright, this is the worksheet for Algebra Section 12, Simultaneous Equations. Simultaneous equations are equations that have the same solution. Simple as that. Right here, we have two equations. These are standard equations that we've seen plenty of times over the course of these algebra videos. If we solve each of these equations, we find that the solution to both is x equals 2. Hence, we've got two equations that have the same solution. Now, what have we just learned? Equations that have the same solution are simultaneous equations. So, nothing weird and wonderful about these. Two equations, same solution, therefore, they're simultaneous equations. Now, this was a really simple example of a set of simultaneous equations. It's really simple because there is only one unknown. An unknown is a thing that you're trying to find. And in these examples, the unknown is x. Note that we might also call x the subject of an equation. However, since we're going to be looking at equations with more than just x, i.e. we might have an x and a y in an equation, we tend to use the term unknowns because it just sounds better than subjects. Therefore, subject isn't wrong, but when we sort of have two subjects, we tend to say unknowns. As I said, the above example was quite simple because it only contained one unknown. When simultaneous equations only contain one unknown, you can solve the equations individually, i.e. you don't need help from other equations. We solved this equation just fine. We didn't need help from this one. Similarly, we solved this equation just fine on its own. We didn't need help from this one. If you have simultaneous equations with more unknowns, then you're going to need more help. In general, if you have two unknowns, you need two equations to help you find what the two unknowns are. Again, if you have three unknowns, you need three equations to help you find what the three unknowns are, and so on and so on. So let's look at an example with more than one unknown. Solve 3y minus 4 equals x and x minus 2 equals 0 simultaneously. To solve these equations simultaneously, we need to find the value of the unknowns in each of the equations. Here, y is an unknown and x is an unknown. Let's go ahead and try this. So first, let's try find y. So we can take this equation here that contains y, and we're going to rearrange it to make y the subject. So we get y is equal to x plus 4 all divided by 3. So we have an equation for y, but without knowing what x is, we can't reduce this equation to what y is, i.e. we can't get down to a number. So we need a bit of help. Like I said, we have two unknowns, therefore we need two equations to help us out. So let's look at the other equation here and see if that helps us. Well, if we rearrange this equation, we get the following. We've found x. X is equal to 2. Perfect. Now that we've got x, we can go back to finding y. So here, down here, back to finding y. We'd already rearranged to make y the subject. Now all we do is plug this value of x into here. So we get y is equal to 2 plus 4 divided by 3, which is equal to 2. Therefore, y is equal to 2. So what have we found? We found x is equal to 2 and y is equal to 2. So we've solved these equations simultaneously, i.e. we've found the values of the unknowns, we've found what x is, and we've found what y is. Now remember, simultaneous equations have common solutions, i.e. the value of x here and the value of y here will work for both these equations, because they are simultaneous. Now, people who've watched my videos before will know I love a check. So let's put these values back into our original equations, and if nothing goes wrong, then we know these are correct. So if y is 2, this term here becomes 6. 6 minus 4 is 2, so we get 2 equals x. Now we know down here that x is equal to 2. Therefore, this original equation becomes 2 equals 2, which seems sensible to me. Note that if you'd have gone wrong, i.e. if you'd have had x as 3, you would have had 2 equals to 3, which doesn't make sense and therefore would flag that you've gone wrong somewhere. Now the second equation, this is actually really simple. There's no y's in here. However, we can check that our value of x is correct, i.e. it should satisfy this equation. So if we put 2 in here, we get 2 minus 2, which is 0. So this equation reads 0 equals 0, which makes sense. Again, if we'd have gone wrong, if we had x as 1, we'd have had 1 minus 2, which would have given minus 1. Therefore, this equation would have read minus 1 equals to 0, which just doesn't make sense. Therefore, you would have known you've gone wrong. So that's a really good check. Just make sure that when you put these solutions back into your original equations, things make sense. Then you know you've smashed it. So here we just did an example of solving two equations simultaneously. In general, there are probably two methods for solving simultaneous equations. One is a substitute method and one is the eliminate method. The substitute method involves rearranging one of the equations to make one unknown the subject of the equation and then substituting that value of the subject into the second equation. That is what we did up here. Yeah, we rearranged this second equation to find x is 2. We then put this value of x into this equation here to find what y was. The eliminate method involves editing one of the equations so that the two equations can either be added or subtracted from one another so that one of the unknowns disappears. I'm going to go over two examples now, and in each of them I'm going to go through the substitute method and the eliminate method. I don't think there's a general rule for deciding when to use the substitute or eliminate method. I tend to find the equations themselves dictate which method to use. I do find that in general, if one of your equations is really simple, the substitute method works best. However, if your equations both look equally as complicated, then the eliminate tends to work. That's not always a sure fast rule, it's just something I tend to find, but we'll go over this in the two examples that I'm about to go through. So here we have 4x plus 5y is equal to 23, and 3y minus x is equal to 7, and we're told to solve these simultaneously. Now, just like I was saying, there is no sure fast method whether to use substitute method or eliminate method. You kind of have to go off what the equations look like. For this one, I'd tend to say that this equation here is probably just as complicated as this equation here. Okay, there's no number in front of the x, but there's still a y term and an x term in both of these. Therefore, for these two, I would have gone down the eliminate method. However, I'm just going to show you both methods. Let's look at the substitute one first. In general, I write down both equations and I label them. So here I've labelled them A and B. Now with the substitute method, the first thing to do is to find which equation you're going to rearrange and which unknown you're going to make the subject. Looking here, I can see that this equation is probably the one to pick because I've got no number in front of the x. Therefore, I can easily rearrange to make x the subject and not end up with any fractions, i.e. if I had a 2 in front of this x, I'd have to divide everything by 2 and therefore I'd get fractions. So I'm going to rearrange and make this unknown the subject. So here we have it. We have x is equal to 3y minus 7. Now the next step in the substitute method is to now take this value of x, i.e. 3y minus 7, and substitute it into your other equation, i.e. we're going to, wherever there's an x in this equation, we're going to put in what its value is, and its value is 3y minus 7. So here we go. This is equation A, but instead of having x here, that 4x, we've now got 4 and then brackets what x is equal to, which we found out from rearranging equation B. Now that we've gone ahead and done the substitution, you'll see that we only have y terms in this equation. Therefore, we can go ahead and solve this, and we get y is equal to 3. Now we know what y is, we can plug it right back into this rearranged equation here. If we put the value of y in here, we can then find x. So let's do that. So we have x is equal to 3 times 3 minus 7. Therefore, x is equal to 2. So we've solved these equations simultaneously using the substitute method. And the solutions are x is equal to 2 and y is equal to 3. Again, I always like to check my answers. So if I take these two solutions here and plug them into these two equations here, I should find that everything makes sense. So if x is 2, this term here becomes 8. And if y is 3, this term here is 15. 8 plus 15 is 23. So this original equation becomes 23 is equal to 23, which makes sense to me. Now the second equation. If y is 3, this term here becomes 9. And if x is 2, this term here becomes 2. So we have 9 minus 2, which is 7. So this equation reads 7 equals 7, which again makes sense. So we're fine. These solutions are correct. Okay, what if we'd gone down the eliminate method? We still start the same. I tend to write out both equations and label them. Now, with the eliminate method, remember, we're going to be adding or subtracting these equations so that we can get rid of one of the unknowns. So what you need to do is you need to look at these coefficients, i.e. the numbers in front of your unknowns, and see if you can get the coefficient in front of the x's the same in both equations, or the coefficient in front of the y the same in both the equations. So if we look at the y first of all, we have a 5 in front of the y and we have a 3 in front of this y. To make these the same, you would have to times this whole equation by 5, which would give you 15 in front of this y. And you'd have to times this whole equation by 3 to get 15 in front of this y. If we have 15 in front of this y and 15 in front of this y, then taking this equation and minusing this equation from it would get rid of the y's. Now, that seems like a lot of work because you have to change this equation and this one. Let's see if we can do something to the x's that is a bit simpler. So the coefficient in front of this x is 4. The coefficient in front of this x is 1. Well, this is really good. This is what you want to look out for when you have a 1 as a coefficient. Because what this means is we can just change this equation here, i.e. we can multiply this equation by 4 so that we get a 4 in front of this x. This means we don't have to change anything to this equation, but what it means is we can take this equation and minus this equation from it, and it will get rid of the x's. So we've got rid of one of our unknowns at minimal effort, i.e. we just have to manipulate this equation. So let's go ahead and do that. So here we go. A is still the same, but equation B has been times by 4. So 3y becomes 12y. Minus x becomes minus 4x, and 7 becomes 28. And I've written them in a different order, so the x's are above and below each other and the y's above and below each other. From here, now you can see that if we take equation A and add equation 4b to it, we'll get rid of these x terms because we'll have 4x plus minus 4x, which becomes 0x, which is 0. So there we go. The x terms have disappeared and we are left with 5y plus 12y is equal to 23 plus 28. Now this equation just includes one unknown, so we can go ahead and solve it. And we get y is equal to 3. Now we know what y is, we can go ahead and take that and plug it back into one of our original equations to find x. Again, choose the equation that looks a little nicer, which I think is equation B. It might take a bit of rearranging, but here, from equation B, we have x is equal to 3 times 3 minus 7. So x is equal to 2. Well, that's great. We've got to the same solutions as we did before, and we know these solutions are correct because we put them back into our original equation. So here, we have the eliminate method and the substitute method. Let's look at a second example. So here we have x squared minus 3x is equal to y plus 2, and y minus 3 is equal to x, and we're told to solve them simultaneously, i.e. we need to find the value of the unknowns x and y that satisfy both these equations. Like I said, there's no rule for which method to use. However, I do tend to find that when there is an equation here that looks pretty simple, I tend to go with the substitute method rather than the eliminate method. So let's go over the substitute method first. Same as usual, write out your equations and label them. Again, with the substitute method, you want to rearrange your simplest equation so that one of the unknowns is a subject. I think equation B looks pretty simple, and I'm going to rearrange it to make y the subject because there's only one y term in this equation. So that makes it a lot easier. If I made x a subject, I'd have to substitute the value of x here and there, and there's a squared term there, and it's getting really complicated. So you can see that it's probably easier to rearrange and make y the subject and substitute it into this one little y here. So there we go, that's easy. Y is equal to x plus 3. Now we know what y is, we can substitute it into equation A. So equation A becomes this. Now we have an equation with just x terms, so we can go ahead and solve that. Now when we started rearranging this, we noticed it became a quadratic. Therefore, we had to do some factorising to solve it. I already did a video on factorising quadratics, so if you're not happy with this bit, I'd probably go and check that out. Solving this quadratic, we get x as 5 and x as minus 1. So if x is 5, putting 5 in here gives y as 8. And if x is minus 1, putting minus 1 in here, we get y as 2. Therefore, we get pairs of solutions. We have the solution x is 5 when y is 8, and the solution x is minus 1 when y is minus 2. Again, you can go ahead and check that these are correct by putting these into these equations and making sure things seem sensible. Remember, if you put in 5 into these equations, you need to use this y here, i.e. these two go together, like peas and carrots. And these two go together. Now, like I said, I would normally use the substitute method for this because we've got a simple equation here and a nasty one there. However, you can still use the eliminate method if you really want. Again, we use the same starting point, we write out both equations and label them. Next, with the eliminate method, we look at coefficients of x and y and see if we can manipulate one of the equations so that when they're either added together or one subtracted from the other, one of the unknowns disappears. Now, to get rid of the x terms, we'd have to deal with an x squared as well as an x term, and that just seems like a nightmare, so I'd already write that off. I'm not going to deal with trying to get rid of these x's. So how about the y's? Oh, we have a y term here, and the coefficient is 1, and we have a y term here, and the coefficient is 1. Therefore, I actually don't need to edit either of these equations. If I take equation A and minus equation B from it, these y's will actually disappear. We'll get y minus y, which is 0. Therefore, let's do that. Let's do equation A minus equation B. Now, I've just written these equations out a bit nicer, so when we're subtracting, we can see what we're doing. Again, you should always help yourself out and do things like this. I always put in extra steps because, well, it helps the marker, and second, it really keeps you on track and stops you from making mistake. So A minus B becomes this here. We get the x squared there, we get a minus 3x from here, and then minus this x from equation B, so we get minus 3x minus x. And this side, we get y minus y, which is 0, and then we have 2, which is here, minus 3, so we get minus 3. This equation just contains one unknown, so we can go ahead and solve it. Again, we've got to a quadratic, so in order to solve it, we have to factorise. And we get to the solutions x is 5 and x is minus 1. So what we do is we take these values of x and plug them back into an easy equation up here. So if we have x as 5 and plug it into here, then we have y minus 3 is 5. Bring this 3 across, we get y is equal to 8. If we have x as minus 1, we get minus 1 here. If we bring this 3 across, we get minus 1 plus 3, which is 2, so we get y is 2. Therefore, we get the same solutions as what we had before. We have when x is 5, y is 8. That's the first pair of solutions. And we have when x is minus 1, y is equal to 2. That's a second pair of solutions. So there, I've gone over quite a few examples of how to solve simultaneous equations either through the substitute method or the eliminate method. I think it's a good point to pause the video and try out these questions here. Then you can come back to the video and watch me working them out. I haven't gone through both methods when working them out. I've just used the one that I would use. If you've used a different one, it's okay. Just make sure we've both got to the same solutions, i.e. we've both found out the same value of x and y. It doesn't matter how you get to the answer so much, as long as you show your workings properly and you get to the correct solution, it's all good. And yeah, I hope this was helpful. Cheers for watching.